This is Matd1544, and we're going to look at Unit 2 now, the trigonometric functions. We're going to first concentrate just on the sine and the cos graph. And in this first video, we're just going to look at, or recording, we're just going to look at the vertical shift and period changes and so on, amplitude changes. No horizontal or a shift or phase shift. Now, remember in school you have done also your sine cos graphs. The point is here that we need now to look at radian measurement and not degrees. So when we look at graphs, we must understand what we mean by the amplitude, what we mean by the period, what we mean by the vertical shift, what we mean by the phase shift or the horizontal shift, and also about the intervals, which was not really done in school, which is a pity, but we're going to do that now, the intervals. To me, that is so important because it makes the graphs so easy. Now, when we look at the sine graph, like you've done in school, we must remember that the normal sine graph has a period of 2 pi. And what is important is that the sine graph starts at the center position, then move to the top, then move to the center, then move to the bottom, and then move to the center. Now, these 4 movements we call the intervals. That is the intervals. Okay, so we will get to now to work it out and all that, but that is important. Now, these 5 points that I was mentioned, center, top, center, bottom, center. These 5 points, we have to fit in a period always. We call it the butterfly, the 5 points forming the butterfly. But there's always these 5 points that forms a period or a wavelength or the cycle of our graph. Right, we know that the sine graph is between -1 and 1 and so on. And then also the cos graph, same story, but the difference is that the cos graph starts at the top, then goes to the center, then to the bottom, then to the center, then to the top. There's your 5 points here per interval, Okay, so when we work with sine graph, we're going to start at the center, and when we work with the cos graph, we're going to start at the top. Now, when I say for the sine graph, we start at the center, if I can just go back here. If I say we start at the center position, please understand that I did not say we start on the x-axis. We start at the center position of the graph because there might be a vertical shift, and then you mustn't think that you must start on the x-axis. So we will look now at that. So clearly there is a 90-degree shift between the sine and the cos graph because they're co-functions. We said so in the previous unit also. And so if I take one of either the sine or the cos graph and I move it by a translation of 90 degrees, I will actually be on top of the other one. Okay, now the center of our graph is always the minimum plus the maximum over 2. I find that always easy to try and find the center first. Okay, but also this center position of the graph will also be the center position of my graph will also be this value of d here. In other words, that is the vertical shift. That is the vertical shift. So the vertical shift forms our central position. Okay, but first let us look now at the notes here, 2.5 for amplitude. Okay, so for the amplitude is always the absolute value of a. And a is what is in front of the function. So Remember, A, the amplitude, will be the absolute value of that number that is in front of the function. Okay, we can also calculate the amplitude by taking the maximum minus the minimum over 2. All right, so if we look here and we see that the maximum is basically say 1 and the minimum is -1. So if I take 1 minus -1, I do get 2. And if I divide that by 2, so it's the maximum minus the minimum over 2, I do get 1 for the amplitude. I myself like to find the center position of the graph, like I said here. And then I know from the center position to the top will also be the amplitude. Okay, but we will look at that now. So let's just look at this example now. All right, just to get the basics in a little bit. So they've given to us here y is 2 minus 3 sine 2 pi over 3x. Just see that there was nothing added at the end there of the function. In other words, I'm sorry, there's a plus 2 I want to indicate. Okay, note that there's a plus 2 there. That's the important thing. Okay, so that is the vertical shift. That should be now the central position of my graph, and that is it. So here's the central position of the graph, and that is at 2. Okay, so if I take the center and I go to the top, I can see that it's 3. So my amplitude should be 3. All right, but I can also take the maximum, which is 5, minus the minimum. So it's 5 minus 1. That gives me 6. And if I divide that by 2, I also get the 3. So it's your choice how you want to find the amplitude. It depends, of course, if you have the graph already or not, if you have to draw the graph. So if you don't have the graph to read from it, then of course you're going to look at the formula here to find the amplitude. Let's also look at the other things we just discussed briefly. Let's look at the period, which we said is 2 pi over b. Now remember, the b is this value here in front of the x, the coefficient of x, the number in front of x. That's the b value. So to find the period, we take 2 pi over that b value. Now here, the value in front of x is 2 pi over 3. So that's why we will have 2 pi over that 2 pi over 3. And that gives us 3 if you work it out. And you will see that this period here is 3, or the wavelength is 3. Okay, now the intervals will be that answer, always that answer, divide by 4. And that gives us then 3/4 or 0.75. So here you can see now that from here to here will be 0.75, 0.75, 0.75, 0.75, making up then the 3. Okay, that's very important. So this is an interval. So remember, an interval is from the center position to the bottom, to the central, to the top, to the central. There's your 5 points forming the butterfly. Now, remember, sine, we said always start at the central position. So it should start at the 2. I said not on the x-axis, at the central position. So it should start at 2. Now, another important thing, this was negative sine. It was -3. Therefore, the graph will start at the center, go down to the bottom, come back to the central, go to the top, go to the central. So it's center, bottom, center, top, center, and then you can carry on. Bottom, center, top, center, bottom, center, top, center, bottom, depending on the length of your graph, how far you want to draw it. But remember, we are concentrating at one wavelength in this course. Okay, so if we look now at examples here, 252 for instance, if I look now here at my maximum and my minimum, which is then 4 and -4. So if I take 4 minus -4 over 2, I'll get 8 over 2, which is 4. Therefore, the amplitude must be 4. Okay, if I look at my central position here, and I look from the center to the top, it's also 4. So that's why the amplitude should be 4. Clearly the central position here is 0. Remember, to find the center, we take the maximum plus the minimum over 2. So it will be 4 minus 4 over 2. So don't get confused how you work out the amplitude and how you work out the center. The amplitude is the maximum minus the minimum over 2. So if we take the maximum minus the minimum, we get 6 over 2, which is 3. So the amplitude is 3. If we take the maximum plus the minimum, so in other words, we take 5 plus negative 1 over 2, we find that that is 2. And that is why the center is 2. And if we now look at the center, and from the center to the top, we get 3 again, agreeing with the amplitude, that's 3, because the amplitude is always from the center to the top. Let's look here. If we take the minimum plus the maximum, that gives minus 2, and we divide that by 2, we get negative 1, which should be the central position. Now from the center to the top should give the amplitude, so that gives 1. If we take the maximum minus the minimum over 2, that gives us also 1, showing that the amplitude should be 1. So again, it depends on how you want to use your skills to find these things, as long as you can find them. If we look here again, the minimum plus the maximum over 2, that gives me minus 3. So that should be the center position. The center position should be at minus 3. And if I take the maximum minus the minimum, and I divide that by 2, I get 2. So the amplitude should be 2. And if I go from my central position to the top, it also gives me 2, showing that the amplitude is 2. So it's not so difficult to work out all these things. All right, for period, we said already that we take the 2 pi over the b value, and we already said also that the b value is what is in front of x. I know you have here 2 pi over omega. You can also use that, but you used b in school, so I just refer back here to your b value, like we did in the start of this recording. Now, remember that the intervals will be that answer always divide by 4. So if we can just look here, all right, and yeah, okay, actually I want to come here, sorry, the example. So that's now 262. Okay, so let us just look here. So here they've given us y is 3 cos 2x minus pi. Now clearly there was no vertical shift, so I just indicated it here with a plus 0 just to show that there is no vertical shift. So our center position should be the x-axis. Okay, the amplitude must be the absolute value of a, and my a value is what is in front of the function, so that is the 3. So I must have the absolute value of 3, which is then 3. Okay, and if I look from my center position to the top, I also see that the amplitude is definitely 3. The period will be 2 pi over b. B is what is in front of x. So it will be 2 pi over the 2 then. And that gives me pi. So in other words, the wavelength or the period should be pi. And that's what we see here, that it is pi. The intervals will be that answer always divide by 4. So it's pi over 4. So in other words, from here to here should be pi over 4, pi over 4, pi over 4, pi over 4. That's the intervals. Okay, because this is the Cos graph, it should start at the top, then to the center, then to the bottom, then to the center, then to the top, making these 5 points every interval. Excuse me. So every interval, we move from top to center to bottom to center to top, etc. So a really easy way of drawing these graphs if we do understand what we're doing. If we look here at this example, so again, there's a +0 there, telling us that the central position is at 0. Okay, so in this case, it is on the x-axis. And then the amplitude must be the absolute value of A, which is then the -2. So it's the absolute value of -2, which should then be 2. And once again, if we look from the center to the top, we see that the amplitude is 2. The period should be 2 pi over b. B is what is in front of the x, so therefore it should be 2 pi over 3. And if I divide that now by 4, I find my interval, which is pi over 6. So in other words, from here to here will be pi over 6, pi over 6, pi over 6, pi over 6. Okay, so if we look at these 5 points, the butterfly, this was the sine graph, but now very important, there's a negative in front of the sine, telling us that we must now start at the center but go down first. So it will be center, bottom, center, top, center to make the 5 points. So the sine graph always starts at the central position, and then if it's a positive sign, we will go to the top. If it's a negative sign, we will go to the bottom and repeat then per interval. So center, bottom, center, top, center, bottom, center, top, center, bottom, center, top, etc., depending on how far we want to go. So if you can just, again on 2.7, the mother graphs, I'm just going to write your MG that you remember this is your mother graphs. You must really know these two graphs very well. So there the 5 points are indicated, and the difference between the sine starts at the central position and then per interval move to top to center to bottom to center. Okay, so center, top, center, bottom, center. And cos starts at the top, center, bottom, center, top. That's the difference between the two. We must just know that very, very well. Okay, so let's move to 2.7.3 to see now how we're going to draw these graphs. So please, I'm trying to teach you the method here. When you get to the test time or exam time, you will have to be able to, of course, do it all by yourself. It's not, but I hope this will teach you what you must do. So once again, there's nothing added there, so our center position is 0. So we always start at the vertical center. Then we find that the amplitude is the absolute value of the value in front of, that's 2. Okay, now if we take the central plus 2, we must reach the maximum. That's why the maximum will be at 2. And if we start at the center and we go down in amplitude, we must go find the minimum. So the minimum should be at -2. And then the period, we said it's 2 pi over b, but b is now that quarter. So it gives us 8 pi. And our intervals is to take this answer and divide it by 4, and that gives us then 2 pi. Okay, so now we start at our first position, which was 0. Because that's where we're going to start, and then per interval. Now the intervals is 2 pi, so that's why we have 2 pi, another 2 pi, 4 pi, another 2 pi, 6 pi, another 2 pi, 8 pi. So we will have 0, 2 pi, 4 pi, 6 pi, 8 pi. Very easy. Now, this is a cos graph. It should start at the top. So it should start at the maximum position. So now we find our 5 points. So 0 must be at the maximum position. And that's why we have 0, 2 there. Then we must come back to the center. So at 2 pi, we must be at the central position, which is 0. That's why we have 2 pi, 0. Then we move to 4 pi, and we must be at the bottom. Okay, so that's why we have 4 pi, -2. Then we must move to the center again, and then we must move to the top again. So there's the 5 points. And then we can just indicate them and we can draw our graph. Remember to always indicate coordinates where it's not on any axis. That is, and the beginning and the end points we must always indicate. So make sure that you do that you don't lose marks. Okay, let's look at another example. This is now a sine graph. So clearly the -2 is the vertical shift. Therefore, the -2 will be the central position. Okay, so the -2 will be my central position. Okay, the amplitude is the absolute value of the number in front. Well, that is 4. So if I take now my -2 plus 4, I will reach the maximum, which is then 2. And if I take then my -2 minus the amplitude, I'll reach the minimum position, which is -6. The period must be 2 pi over the value in front of x. So it's 2 pi over 2. That gave me 4. And I must divide that by 4 to get the intervals. Right, so now I start at 0 and add intervals. So I must start 0, add 1, add another one, add another one, add another one. Right, now this is a sine graph. And it's a positive sine graph. So this sine graph should start at the central position, which is -2. So when I go to 0, I must be on -2. So 0, -2. Then I must go to the top. So the top was 2. So it's 1, 2. Then I must come back to the center. Then I must go to the bottom, which is at -6. So at 3, I must be at -6. And then I must come back to the center. There's my 5 points forming the butterfly. All right, now I just indicate them and I can draw my graph. So central, top, center, bottom, center. Okay, and there I have one wavelength, one period, the sine graph being drawn. From the center to the top, I can see what the amplitude is, which is 4, which agrees with my 4. All right, so very easy way to draw these graphs. Let's look at this Cos graph. Okay, so I just rewrite this graph so that I can see, that this is in the way that we are used to A cos Bx, as I said. Okay, so the central position here is 2, so that should be the center. My amplitude should be the absolute value of the number in front. That gives me my 3. If I take the center plus the amplitude, I must get my maximum. If I take the center minus the amplitude, I should get my minimum. My period must be 2 pi over the number in front of the x. That's 2 pi over 3. And I must divide that by 4, that thing by 4. It gives me pi over 6. So now I know my intervals will be pi over 6. So now I go fill in. I start with 0 and add pi over 6. So 0, add pi over 6, add another pi over 6, add another pi over 6, add another pi over 6. Here you can see that you are getting the period of the graph back. That's important for you to check that, because, you must end at one period. Okay, so this is a sine graph. This is a cos graph, but it's a negative cos graph, so it must start at the bottom position. So when I do my 5 points now, my first one must be at the bottom, at the minimum. That was at -1. So my 0 will be at -1. Then go to the central position with the next one. Then go to the top, come back to the center, ending up at the minimum. And there we are. And please indicate the coordinates that is not on any axis, all beginning and end values, that you do not lose any marks. So here's my bottom, center, top, center, bottom, forming my 5 points per period. 4 intervals, 1, 2, 3, 4. For intervals, 5 points per wavelength. I really think that this is not difficult if you apply this method. I hope you get it right. In the next recording, we will then look at how do we do the phase shift.